whole square. Whenever the h is having the appreciable value with respect to the r, whenever h is much lesser than r, otherwise percentage of h is less than how much? 5%. If it is less than or equals to 5%, and also I said the value of that h also, h is approximately less than or equals to 320 kilometers. In this all cases, what you have to use, gh is equals to g into 1 minus 2h by r. We have applied the binomial expansion. Binomial expansion will be always useful, remember that. We have taken that 1 plus x whole power n is equals to 1 plus nx. If and only if. What is the condition? Main condition is x should be less than, much lesser than 1. X should be much lesser than 1. At that time 1 plus nx. The same method we have applied here also, and then we got this answer. Gh is equals to g into 1 minus 2h by r. Next one is variation of g with respect to the depth. With the depth we have only one formula. With the height it will be two formulas with respect to the height values. Now variation of g with respect to the depth, gd is equals to, what is the formula? G into 1 minus d by r. Just remember, here 2h by r will get, here just d by r will get. That is a gd value. And also after that we have discussed the variation of g due to the rotation and also variation of g due to the shape of the earth. In these two cases, what happening? G is increasing or decreasing? In two cases, g is decreasing only. See that, g minus g 2h by r, nothing but you are removing some value from g, so that g value is decreasing there. In the depth also it will be decreasing only. Whenever you are going above the earth surface or below the earth surface, then what happens? G value will decreases, and also on the earth surface it will have the maximum value. What is that maximum value of the g? 9.81 meter per second square, 981 centimeter per second square, and also 32 feet per second square. So that those are all the values of g. However, in this both cases g value is decreasing only. Next case is due to the shape of the earth, where the g will be maximum, at equator or at pole? Where the g will be maximum? At poles. I said whenever the person is moving from the equator to the pole, at that time his weight will increases. So here I said one more concept very important, that is r of the pole is equals to how much? R of the equator minus 21 kilometers. R of the pole is equals to R of the equator minus 21 kilometers you have to take. So that again R of the equator is equals to, I can even write as what? R of the pole plus 21, anything is correct only. So at equator more radius is there. More radius, nothing but what I can say? Less g is there. At poles less radius is there, means we will have more g. Why? Because g is inversely proportional to r square we had yesterday, right? Next, due to the rotation. Now I said very important, that is whenever the person is moving from equator to pole, his weight will increases, g value will get increases. Then after that, whenever you see the rotation, due to the rotation we have discussed, whenever the earth is rotating and the particle is in rest on the earth surface, then what happens? Whenever you are looking from outside, which motion that will be? Circular motion. Which circle? Horizontal circular motion. Centrifugal force will act in which direction? Radially outwards, exactly in horizontal direction, correct? And also radius vector is making angle theta with the equator. At that time, opposite to mg, what will get? Which component will get? Opposite mg, which component will get? Normal reaction and fc cos theta. Fc is equals to what we have written? M omega square into r we have written. That and all we got. By that, the apparent weight, who has given the apparent weight for us? Normal reaction. So that mg dash is equals to what we have written? Mg minus mr omega square. I am sorry, Kepler I guess. No, we have changed, after that. Mr omega square cos square theta. Correct formula is? Next. First smaller, after that I have put here cos square. If here cos theta means small r cos theta we will get. Capital R means small r is equals to capital R cos theta we got, so that r cos square theta we got here. That is correct only. Now in this also at poles theta is equals to how much? 90 degrees. At poles 90 degrees means what will get? Mg dash is equals to just Mg, then G dash is equals to how much will get? G only. At equator theta is equals to how much? 0 degrees. Theta is 0 degrees, nothing but what will get here? G dash is equals to G minus what will get? M R omega square. R omega square will get. That is what we got, and then we have discussed already at equator G will be less and at the poles G will be more. So only G is less here, G is more here, because we are removing R omega square from G. So it is a less only. These and all we have discussed yesterday, right? Next, weightlessness, condition for weightlessness. Condition for weightlessness. Condition for weightlessness. Condition for weightlessness. What do you mean by weightless? What do you mean by weightless? There is no weight. There is no weight, nothing but there is no mg, right? So, condition for weightlessness nothing but that is apparent weight. We are discussing about the apparent weight here. Due to the rotation of the earth, what is the weight equation we got? Apparent weight equation. Due to the rotation of the earth, apparent weight is equals to what? Normal reaction only, right? That normal reaction is equals to what we got? Mg dash is equals to. Pause that video, ma, Deepika. For weightlessness, we have discussed that yesterday. Apparent weight mg dash is equals to. Mg dash is equals to what is the equation we got? Mg minus m into r omega square cos square theta. That is what the equation we got. I said weightlessness. Weightlessness nothing but which will be 0? Mg dash is 0. Not mg. Mg is the original weight. Who is giving the apparent weight? We are feeling. Weightlessness nothing but we are feeling that we are not having any weight. Not having any weight nothing but feeling means what? Appearing. So apparent weight is how much? 0. So this is 0 means then mg is equals to what will get? Mr omega square cos square theta. From this what you have to derive means you have to derive the value of omega. Why? Because in the rotation we said that the earth is rotating with angular velocity omega. So what is the original value of the omega? First of all you have to tell that, and after that at what value if it is rotating, at that time person will feel weightlessness. The fixed value of the radius is how much for us? 6,400 kilometers, and then whenever you substitute the g value as 9.8 and then theta as 0, already we got that g minus r omega square is equals to g dash, right? By this equation what will get? Nothing but omega of the earth is equals to, and also from the escape velocity and then orbital velocities also will get the equation only. Omega E is equals to 7.27 into 10 power minus 5 radian per second. Whenever we will discuss the satellite topic, at that time I will tell that how it came and all. So omega E nothing but the angular velocity of the earth is with what speed it is rotating present nothing but with 7.27 into 10 power minus 5 radian per second, that much slowly. So only in 24 hours it is covering only one rotation. Understand, right? One spinning it is happening, it is just revoluting for one time nothing but it has to rotate with very slow, with very less speed. So that less speed is how much? Nothing but omega E is equals to how much? 7.27 into 10 power minus 5. At present that is the value. Now you want to feel the weightlessness means what happens? What should happen? It has to spin with more speed, otherwise less speed. More speed, right? For example, I am just rotating. For example, on this bottle, on this water bottle outside, water drops are there. So weightlessness has to appear nothing but what I have to do? I have to spin it with more speed or less speed? More speed. Then only it will fly off outside. So with more speed, how much more speed we have to apply for that? That and all we will find out here. I am saying that here condition for the weightlessness. So which condition is there? Nothing but by the omega only. At what value of angular speed we will feel weightlessness? So that value only you have to find out. That will be how many times of the present value, that we will find out. So that is the present value of the earth rotation is how much? 7.27 into 10 power minus 5. Now here m gets cancelled. Omega square is equals to what I can write here? G by r is equals to G by r 1 by cos square theta is equals to what I can write simply? Omega square. Then omega is equals to what I can write? 1 by cos theta under root G by r. 1 by cos theta under root G by r. For example, I don't know the angle where we are measuring. Let us consider reference angle is equator only. At equator, theta is how much? 0, right? Radius vector makes how much angle? 0 degrees. So that theta is 0 degrees where? At equator. At equator this is 0 means cos 0 is how much for us? 1. Then omega is equals to under root G by r. Under root G is how much for us? Let us take 10 approximately. And then this will be 6,400 kilometers. Then 0 gets cancelled. 6,400 kilometers, no? Kilometers nothing but this is meter per second. So that 10 power 3 also I have to take. Correct? 6,400 kilometers. Kilometer nothing but 1000 meters we have to take. Why? Because G value is how much? 10 meter per second square. Everything should be in meters only. Then what is remaining? 1 by 800. 1 by 800 nothing but 10 power minus 2 into 1 by 8. Then this value will be how much? 0.125 I guess. Correct? 0.125 into 10 power minus 2. Then 1.25 into 10 power minus 3 radian per second. For example, if in case the earth is rotating at this speed, then what happens? Nothing but the person standing at the equator will fly off into the space. You understand the concept, right? So present value is how much? General value of the angular velocity is 7.27 into 10 power minus 5. Then nothing is happening. Everything is going happily and then everybody is standing on the earth only. Whenever the earth is spinning at this much speed, then what happens? Nothing but whoever are there at the equator, they will fly off into the space. Clear, right? Everybody understood? So this, for this one, this is how many times? Nothing but 17 times. So the omega, now whatever the omega we are having to weightlessness, omega dash is equals to 17 times of omega. At that time what happens? Nothing but whoever standing at the equator, they will fly off from the earth. It will be 17 times. Okay. So that is what about the weightlessness condition. Everybody understood, right? Shall I explain again? General value of omega is how much means this is a reference value 7.27 into 10 power minus 5. We will find out the omega value for weightlessness. Weightlessness nothing but simply the person has to fly off into the space. Whatever the objects, otherwise person, anything. Now here whenever we see the apparent weight formula, apparent weight due to the rotation, we are feeling that weightlessness due to the rotation only. Whenever we are spinning with more speed, at that time what happens? Nothing but objects will be fly off into the space. So that omega value only you have to find out. To find out that omega value, we are having already apparent weight formula mg dash is equals to mg minus mr omega square cos square theta. Yesterday itself we got that. Now m gets cancelled everywhere, and also I am feeling weightlessness nothing but apparent weight is how much? 0. And then also I said in the relative motion concept, I think we are feeling nothing but what? That is a apparent velocity. It is appearing. I said that it appears, the person will see, and then it appears in Rainman problems mainly. The rain appears nothing but that is the relative velocity. Relative velocity of the rain with respect to the man. In the same way, here also he is feeling the weightlessness nothing but apparent weight becomes 0, not the original weight. You should not take this as 0. You have to take apparent weight as 0. Now apparent weight is 0, then mg is equals to mr omega square cos square theta. Then m gets cancelled everywhere. Omega value is how much? 1 by cos theta under root g by r. For reference purpose, I will take at the equator. At equator theta is equals to how much? 90. So at theta is equals to 90, theta is equals to 0, then omega is equals to how much? Under root g by r will get, that value is how much? 1.25 into 10 power minus 3. It is rotating at some value. For example, if in case, if the earth is rotating at this speed, then what happens? whoever are there at the equator, they will fly off into the space. Clear, right? For example, at poles, if we measure at poles, then what happens? Theta is equals to 90. If cos 1 by cos 90 value is how much? Cos 90 is 0. 1 by 0 nothing but what will you get? Infinity. Nothing but already I am standing at the poles only. I am holding the poles. Near the poles I am having. So whenever I am there at the near the poles, there is no chance to fly off only. For example, water drop is there on the cap. On the cap very near to the axis of rotation. There is no chance to fly off only. That is very near. Whenever you see the moment of inertia, I is equals to mr square will get up. So that r is very less, nothing but moment of inertia also very less. There is no chance to fly off from there, from the poles. But at the equator, we can easily fly off with what angular velocity? 1.25 into 10 power minus 3 radian per second. Clear, right? Copy that. Weightlessness. Not that much important, but just remember this value. పట్టుకో ఇలాగా. Whenever the earth is rotating at this speed, what is the time period for one rotation? 24 hours. Present value only. Earth is rotating at this angular speed, time period is 24 hours. If in case earth is rotating at this speed, what is the time period? Nothing but just 1.4 hours. In 1.4 hours, earth will complete its rotation. Clear, right? Why? Because here omega is equals to what is the formula in terms of time period? Omega is equals to what is the formula? 2 pi by t only, right? Angular displacement by time only 2 pi by t. From that if you calculate, you will get the time period how much? 1.4 hours. I will tell that note point. Finished? Write a problem, not write a note point. If earth will to rotate, if earth will to rotate 17 times of, if earth will to rotate 17 times of its present angular speed, then the body lying on the equator, would fly off into the space. In the next line, the time period of earth for one rotation, at the condition of weightlessness, T is equals to 1.4 hours. T is equals to 1.4 hours. Whenever weightlessness is there at the equator, at that time period is how much? In one day will be over within only 1.4 hours. Because now it is rotating at this speed, so that our 1 day time period is how much? Nothing but 24 hours. That you have to remember. Then next one is variation of G. Variation of G with height and depth problems. For that one concept is there, I will tell that first. Variation of G with height and depth problems. See, yesterday in study hour have given some problems. Those are very easy. Directly we have to find out the height. Otherwise we have to find out directly. I think in one of the problem height they have given as 1 kilometer. Yes, sir. We have used which formula? GH is equals to G into 1 minus 2h by r we have used. I think one more depth problem. I said depth and then height both are equal. I said that GH and then GD are equal. At that time what is the D value, like that I asked, I guess. Correct? So that it was also very easy. We have written the GH formula and then GD formula, and then after that we got the D value directly. Now here is whenever they have given percentage change for the G, then what we have to do? Percentage change for the G in case of GH or in case of GD. Yes, you have to apply the error method there. See that, for example, they have given so and so percent, G is changing for X percent. Then at what height G will have 1% of present value. Otherwise at what depth G will have 10% of its present value. You understanding the question, right? So G is present at what value? What is the value of G? 9.8. Whenever you are going to height H, then what happens? Nothing but G will decreases. G is decreasing, nothing but, let me take at what height G is 90% of present value. Otherwise at what depth G is 60% of present value. If the problems has given like that, then what you have to do? So here first of all, GH is equals to what is the formula? G into 1 minus 2h by r. I said that G is so and so percentage of the present value. Nothing but G is changing or not changing? G is changing. So that G is changing means, shall I take that as delta G by G? Percentage change in the G is what? Delta G by G into 100 only we will take, that is the percentage of change in G. For that delta G means what? Change in G. So that initial value minus final value we will get. So initial value of G was how much? G. Final value is how much? GH. So that whenever you do the difference between them, then what will get? Nothing but percentage change will get. I will do that. So that delta G I wanted to find out means, for that first of all G minus GH I will do. Initial value minus final value only will get. G was the initial value. Now at what height they have given? Nothing but at GH height, at the height of H they have given the G value, G minus GH. So that G minus, what is the GH formula? GH formula is G into 1 minus 2h by r. So that G minus G minus G into 2h by r. Correct? I sent G inside, that's it, I have not done anything. So that this will be what? Delta G obviously. At the end of the day I have to get this one. Yes, yes. At the end of the day I have to get this one, delta G by G. So for that G gets cancelled here. So delta G is equals to G into 2h by r. Then delta G by G is equals to what will get? Just 2h by r. So this is how you have to do. Then delta G by G is so and so percent at this much of height, it will happen like that. Whenever I give the problem, then you can understand that easily. So here the main problem is that wherever they have given directly height, directly depth, nothing but easily everybody can do that. But now they have given most of the people will have problems with this only. They cannot solve percentage problems that much easily. The thing is mainly you are not analyzing the problem properly. Always any percentage they have given nothing but simply you have to apply delta G by G only. That might be delta X by X, delta L by L, whatever it might be. You have to take change by the original value only. In the collision also I said fractional change in kinetic energy. What we got there? Delta K by K only. K initial minus K final by K initial we got. In the same way, anything, any fractional change, always you have to take change in the value by original value itself. First of all, I want to get the fractional change of G means, first of all I have to get the delta G. Delta G means initial value G minus G value at height h. So, G minus GH, G minus of GH value is G into 1 minus 2h by r. I send G inside, G gets cancelled here, one more GH, G into 2h by r is there. Now, this is what delta G only. That delta G by G is equals to what is remaining for us? Just 2h by r. In case of depth, what is that in case of depth? Again delta G means what you have to do? G minus GD you have to do. Whenever they are talking about the height, then G minus GH. Whenever they are talking about the depth, G minus GD. So that G minus GD is equals to what we will get here? G minus, what is the GD value? G into 1 minus D by R. This is what delta G. Delta G is equals to G minus G plus GD by R. Then delta G by G is equals to simply D by R only. The second term only we will get 2h by R and then D by R. Whenever they are talking about the relation between the percentage change in the G and then depth, then delta G by G is how much? D by R. Whenever they are talking about the percentage change in G and height h, at that time delta G by G is how much? 2h by R. Clear, right? This is what the formulas you have to use for the problems. Copy that. Given percentage change in G and height. మార్నింగ్ నుంచి ఇలాగే ఉందా మార్కరు సరిగా రాయట్లేదా దీపిక గుడ్ మార్నింగ్ దీపిక లేదు నేను లంచ్ ఈరోజు హాస్టల్లో చపాతి అన్న సారు What? Either, but less than 5%, then you have to apply this one. See, when this method can be used? What percentage? Less than 5%. I said this one already. Whenever the percentage change is there in less than 5%, then only you have to use this one. Otherwise, more than 5%, let me take 50%. Directly you can do here only, no? GH is 50% of G, nothing but what you have to use? G by 2. Then G gets cancelled, directly you will get the H. Correct? This will be applicable only at less than 5%. Write that also, otherwise you will get confused. Finished, huh? Next, write a problem. At what depth below? At what depth below At what depth below the earth's surface the acceleration due to gravity is decreased by 1%. How much? Very good. Pen kodu onnondi. Pen. Illa onnondilla. Finished? At what depth below the G will decreases by 1%. 1% nothing but less than 5%. So which formula you have to use? Delta G by G is equals to D by R. Find out the D value. 64 kilometers. That's correct. Very good. Clear? 64 kilometers is the answer. Nothing is there here. Delta G by G is how much they have given? 1% is equals to D is how much you have to find out. R is how much? 6400 kilometers. Then this is 1 by 100, no? Then 100 gets cancelled. Then D is equals to how much you will get? 64 kilometers. That's it. Next problem. At what height above the earth's surface acceleration due to gravity will be 1/9 of its value, 1/9 of its value at the earth's surface. How much? 400. Check that properly. H is equals to? Very good. Very good. 128,000 kilometers, you will get the answer. H is equals to 2R. H is equals to 2R is the answer, correct. Still you did not get the answer. H is equals to 2R is the correct answer. How many of you got that? Very less, only 4 members in the class. See that GH is equals to, what is the basic formula of GH? GH is equals to GM by R plus H whole square we got. And after that, they are saying that at what height above the earth's surface, G value is how much becoming it as? GH is equals to 1 by 9 times of G value on the earth. So that here GM, I want small g, nothing but what you have to do? Take R square common, what is remaining here? 1 plus H by R whole square. This is what now we got. Then GH here. What is the GH value they are saying? 1 by 9 times of G. So that 1 by 9 times of G is equals to, what is the GM by R square here? G, that divided by 1 plus H by R whole square. G gets cancelled here. Clearly 1 plus H by R is equals to how much I can write? 3. Then H by R is equals to 2. H is equals to 2R. Why you are taking this much time? H is equals to 2R directly. Any confusion in that? Did I say H is much lesser than and all? Then why you are applying that formula? I think all of you might be applied 1 minus 2H by R only. Next, at what depth? At what depth from the earth's surface at what depth from the earth's surface does the acceleration due to gravity becomes 1 by 4 times of its present value. How much? 3 by 4 R. Very good. Three by 4R is the correct answer. You got that? Only one formula. For height we are having how many formulas? 2 formulas. But for the depth how many formulas are there? Only one formula. Apply that. That's it. You will get the answer. Next, write a problem. Everybody got right? Shall I do that? You got right, everybody? GD is equals to G into 1 minus D by R. Only one formula is there for us in case of depth. In case of height, 2 formulas will be there. For in case of depth, only one formula is there. GD is how much I am saying? G by 4. G gets cancelled. Then D by R is equals to 3 by 4. Then D is equals to 3 by 4 times of R. That's it. Then write the next problem. Determine the speed with which Earth would have to rotate about its axis, about its axis, so that the person on the equator, weighs 3/5 of the present value. 3/5 of the present value. Get the answer in terms of R. Omega you have to find out. This is just one more condition in the weightlessness. G, that's it. Where is the R? Very good. Under root 2G by 5R, I think. Yes. Under root 2G by 5R. Apparent weight is how much they are saying? 3/5, that's it. 3/5 only. Omega is equals to under root 2G by 5R is the answer. You got that? How many of you got? Raise your hands. What about the remaining people? You people are sleeping, I think. Apparent weight, what is the formula? Apparent weight due to the rotation? mg dash is equals to what is the formula? mg minus mr omega square only, right? Mr omega square, however, cos square theta. What they are saying, a person at the equator is having how much weight? 3/5 times of the original weight. So this is apparent weight they are saying, that is equals to mg minus mr omega square. At equator nothing but cos square theta becomes how much? 1. Why? Because theta is equals to how much? 0. At equator theta is equals to 0 degrees. Then m gets cancelled everywhere. Then 3/5g minus g minus 3/5. G minus 3/5g is equals to what I can get? R omega square. Then 1 minus 3/5 nothing but what will get here? 2/5g is equals to R omega square. Then omega square is equals to 2/5g by R. Then omega is equals to under root 2g by 5R. This is the answer. They are saying that a person at the equator feels how much weight? 3/5 times of the original weight. That's it. At equator they are saying, so that theta is equals to how much? 0 degrees. One more problem. The maximum vertical distance through which an astronaut can jump on the earth is 0.5 meters. Is 0.5 meters. Then estimate corresponding distance on the moon. Estimate corresponding distance on the moon. What is the answer? Very good. Directly H and G relation you take. H is equals to U square by 2G only, no? Then H is inversely proportional to G, that's it. You'll get the answer. Not yet done. H is equals to how much? 3 meters you will get. So always height is equals to H is equals to, what is the formula you will get? U square by 2G. Then directly what I can write? H is inversely proportional to G only. However, he will jump with the same initial speed, so that H on the moon by H on the earth is equals to G on the earth by G on the moon. H on the moon you have to find out. H on the earth is how much they are saying? How much? 0.5. 0.5 nothing but 1 by 2 I will take. That is equals to G on the earth is G. G on the moon is how much? 1 by 6th of G on the earth. Then this will be how many times? 3 times it will go. Then H on the moon is equals to 3 we will get. 3 meters is the answer. That's the answer. Next problems. Next problem. Weight of the body decreases by 1%. Weight of the body decreases by 1% when it is raised to a height. When it is raised to a height H above the earth's surface. When it is raised to a height H above the earth's surface. Full stop. If the body is taken to a depth H, taken to a depth H in a mine, then its weight will options decreases by 0.5%, decreases by 0.5%, decreases by 2%, increases by 0.5%, increases by 1%. That one you can do. Next problem. At what height from the earth's surface? Next problem. At what height from the earth's surface does the acceleration due to gravity, at what height from the earth's surface does the acceleration due to gravity decreases by 1%? Decreases by 1%. Next problem. At what height from the earth's surface? At what height from the earth's surface Does the acceleration due to gravity decreases by 75% of its value at the Earth's surface. Next one, last problem. At what depth below the surface does the acceleration due to gravity becomes 70% of its present value on the surface. Clear? That problems you can do. Next one, gravitational field and then gravitational field intensity. Gravitational field and then gravitational field intensity. So what do you mean by gravitational field? Just related to the electric field. Whenever you see the electrostatic force is F, then what is the electric field? Force by unit charge. Force acting on the unit test charge we call it as. So whenever the force acting on a test charge, then we can say that is a electric field intensity, otherwise electric field. Now here gravitational field intensity is nothing but, here instead of charge what will have here? Mass, that's it. So there electric field E is equals to, what is the formula we will get? F by Q naught. In the same way, here gravitational field intensity I is equals to, what will get? Gravitational force divided by, instead of charge what will get? Mass we will get. I is equals to F by M. Can you tell me the units of that? Newton per kg only. Newton per kg means, can I say that is meter per second square? Newton is nothing but what? Kg, meter per second square divided by kg. So that kg gets cancelled. There what will get? Meter per second square. The intensity and then gravity values will be same only always. But that is a vector. Here this will be the field we are discussing about. However, it is also field, it is also a vector quantity only. Now I is equals to F by M. The gravitational force acting upon a unit test mass, then we know it as what? Gravitational field intensity. The electric force acting upon a test charge is called as what? Electric field intensity. Now here I is equals to G by M I have taken, not G by M, F by M. Now I have a mass, reference mass we are having M, and at a distance R, a unit mass is there. Unit mass nothing but how much? M is equals to 1 kg we have to consider. A unit mass is there at a distance, let me take, in this direction I am just measuring the position vector, that is what? Nothing but R bar. So R bar is the position vector here. From where we are measuring? From the mass to the unit mass. Here direction is very important. You might be studied somewhere that all the attractive forces are negative. How it is negative we will discuss here. Might be seen that whenever attractive force is there, at that time we will get minus. Whenever repulsion force is there, at that time we will get plus. How it come and all we will discuss now. So here mass is there at a distance R bar, position vector nothing but from the reference to the final point only you have to measure. For example, I am observing you people are doing so and so work, means From where we are measuring? We have to measure from me, from the observer to the object. Observer to the object only. Here observer is what? Mass, and then object is what? Unit mass we will consider. So position vector is there in this direction. Now this mass is doing what for this? What it is doing? Attraction, right? Gravitational attraction only. Attraction nothing but pulling or pushing? Pulling. Pulling nothing but in which direction? In this direction it is pulling. This mass is applying the force in this direction on this test mass. Okay. So that it is applying the force in this direction, that is F. Now whenever you see this F and then R, both are opposite to each other. Now again, whenever you are discussing about the intensity, what is the intensity formula for us? F by M. F is nothing but what? G into M into small m divided by, what is the position vector here? R square divided by M again. This M and then M is how much? 1 kg only. Then what is remaining for us? Gm by R square. And also it is a vector quantity, so that we have to discuss with the position vector also. So to get the vector form, what you have to do? We have to get in vector form, nothing but what you have to do? You have to multiply with unit vector. So that unit position vector is how much? R cap. But now this force and then R bar both are opposite to each other. So that what will put here? Minus. Then clearly what I can write here? Gm into minus R bar divided by what will get here? R cube. This is the intensity. Gm by R cube. However, I said in the force also, what we got the formula in the vector form? Gmm by R cube into R bar. But here on the test charge, this mass is applying the attracting force. You might be think that even this is also applying the force only. On the bigger mass, 1 kg mass also applying the force. But what I said, this is a test mass. You already got in the electrostatics. Test charge nothing but on that we can do the experiment, but that will not affect any experiment. You understanding or not? You are just experimental piece only. You cannot affect anything there. This is a test mass. It cannot affect any body. Just it will be affected by the other bodies. So here this will be getting attracted by the bigger mass, but it cannot attract anything here. So that we call as what? Test mass. Otherwise in the case of electrostatics, that is test charge. So many people will do that. Their test charge is Q naught nothing but again they will put Q naught by R square. One more it is applying the force in the opposite direction, like that they will take. But the test charge is nothing but we can do the experiment on that, but that will not affect any problem for us. We are affecting that, but that will not affect us. In the same way here test mass also there. On the test mass, capital M is applying the force in which direction? Towards that only. Why? Because which force here? Attraction force only, gravitational attraction force. So attracting in this direction, and the position vector is there from the capital M to small m. Whenever you see both are opposite to each other. Whenever both are opposite to each other, we know the intensity formula. I is equals to what is the formula? F by m. From that what will get? Gm by R square. I want to get in vector form, so that I have to indicate with the position vector. This position vector and then force both are opposite in direction. So only I am taking here minus R cap. This is a unit vector. If you are multiplying or you are not doing anything, nothing will happen there. But I want to get in the position vector form. So R cap is equals to what I can write? What is R cap? R by modulus R. So that modulus R bar by modulus of R square by R square into R is how much? R cube here. Then I bar is equals to Gm into minus R divided by R cube. This is very important in the graphs. Why? Because in graphs, whenever you see due to the hollow sphere and then due to the solid sphere, in the Gauss theorem you will get that. Due to hollow sphere and then solid sphere, how to get the graphs? Nothing but see the electric field intensity and then R if they have taken. At that time what kind of graphs you will get? You will get this kind of graphs. Do you know that? You got that or not? You are studying electrostatics or not? Yes, sir. I don't think so. You are studying at least long term. You are there in Davangere. Otherwise any weightlessness for you and then you gone to somewhere else into the space. No, in the afternoon first hour means always weightlessness only. Weight on the benches and then weightlessness in your brains. This is what the graphs you will get. But in case of gravitation, even in this also, whenever the charges are attractive, nothing but charges are opposite charges, at that time you will get the graphs in this way. This is the graphs you will get, like this you will get. So if you don't know sign convention, then you will get confused between the graphs. For example, they have given two graphs, then you will get the negative marks. Why? Because you will always consider this only. So here what I said, intensity is equals to Gm by r cube minus r. Minus r nothing but you will get along which axis, which plane? Negative xy plane or positive xy plane? Negative xy plane. We will discuss that, however, we will discuss and then we will draw the graphs. Write that gravitational field intensity. Gravitational field intensity. Copy everything, you know already. What is that? The gravitational attraction force acting upon a unit test mass. Unit test mass. Copy that. Write a problem. Find gravitational field intensity for a hollow sphere at points outside of the sphere. First question, outside of the sphere. Next one, on the surface of the sphere. On the surface of the sphere. Next one, inside of the sphere. I am saying that you have to find out the intensity at 3 points for which sphere I said? Hollow sphere. So, in case of hollow sphere, first is what? Outside. Next one is inside or on the surface? On the surface. Then third case is inside, you have to find out. For this graphs also will be there, those are important. Now here, whenever I have taken a hollow sphere of, let me take radius r. Hollow sphere of radius r I have taken. First case is what? Where you have to find out? Outside of the sphere. Outside of the sphere, let me take at r distance from the center. At small r distance from the center, here you have to find out. This is a point P. At that point, at this point, for example, I said just before, at this point P, test mass is how much we are taking? M is equals to 1 kg. So that at this test mass, at this point P, what is the intensity for us? I is equals to, we got how much? Gm by r cube into minus r bar. That is what we got. In vector form you have to take. So here also the same thing is happening. Always you have to measure the intensity from the center of the earth, otherwise center of the sphere, whatever we have considered. Now here at this point, at what distance the point is there? Small r distance. Just forget about the radius of the sphere only. Directly our main intention is you have to measure from where? Center to the point P, that's it. Always in case of earth also, always we will measure the mg towards the earth center only, no? Height also from where we will measure? Gh is equals to, what is the formula we got? Gm by r plus h. We did not get only h, we got it as how much? R plus h. From where we measured it? From the center to the point P. In the same way, here also you have to measure from the center to point P. What is the distance? That is r is the distance. Now you have to find out the gravitational field intensity. I is equals to G into mass of the sphere is, let me take capital M, Gm divided by, what will get here? What is the distance? What is the distance here? Small r cube. You just forget about the radius. I am not talking about the radius. On the surface nothing but you have to take capital R only. Otherwise whatever the original distance they have given, that only you have to consider. So that what will get here? R cube into minus r bar will get. Correct? That is only no formula we got. Then on the surface, second case is on the surface. On the surface, what is the distance now? On the surface means what is the distance? Capital R only, right? So that I can say that r is equals to capital R. This is the point P. So at point P, the intensity is there like this towards the mass only, obviously. It will get attracted towards the mass only, right? So that towards the mass it is there in this direction. On the surface it will be maximum. How much maximum is? I is equals to, simply what will get? Gm by, what is the distance now? Capital R square. R cube into R only again. How much will get? R square. Gm by R square will get. Then next case is inside. Now tell me the answer. Inside, let me take point P. This is the R at small r distance. What is the intensity inside of the hollow sphere? Zero, right? Where there is no mass, there is no gravity. Where there is no charge, there is no electric field. If charge is not there, then what is the electric field? Zero only, nothing will be there. In the same way, where there is no mass, there is no gravitational field also. So that here gravitational field is, how much means? That is zero only. Inside we are measuring. Inside means don't take again small r, again don't take it as Gm by r cube into minus r. Inside means mass is how much? Where the mass is present. For the hollow sphere I said. Hollow sphere nothing but where the mass is present? Only on the surface. Inside is there any mass? Nothing is there, air is there. There is no mass. So that inside mass is how much? Inside mass is 0. Mass inside is 0. So that intensity is how much? 0. Clear everything? Then outside at what distance we are measuring? R distance, so that easily we can get that I is equals to Gm by r cube into minus r. Why? Because this always gravitational force is which type of force? Attractive force. Attractive nothing but force will be there towards. Towards it is there nothing but that will come as how much? Minus. Repulsion force nothing but what will get? Plus we will get. So that Gm by r cube minus r bar. Then next case is we are just discussing on the surface. On the surface there will be a maximum mass will be there for us. So maximum mass will be there and the distance is how much? Small r is equals to capital R only. So that directly I is equals to Gm by r square will get. Next inside mass is how much? 0. If there is no mass, there is no gravitational field. So that I is equals to how much? 0 here. Then whenever I draw the graph for that, graph for 3 cases, this is the gravitational field intensity and then this is the distance r. Now let me take, this is the distance where small r is equals to r. This is the area where small r is less than r. This is the area where small r is greater than r. So in the first case, what is the relation between capital R and then small r? small r is greater than capital R. Second case, small r is equals to r on the surface. In this case, that will be small r is less than the capital R. Whenever small r is less than the capital R, I is equals to how much? 0. So that in this area, what will get? 0 intensity. 0 intensity, nothing but there is no change, nothing. Here directly 0 we will get. Next, at I is equals to what is the formula we got? At where r is equals to r. At that time, what we are getting? I is equals to gm by r square. Attractive or repulsive? Attractive. So that what will get here? Minus we will get. So that minus gm by r square. At some value, the value is minus gm by r square. This is the maximum intensity. So that at r is equals to r, we are getting minus gm by r square. Whenever you take r greater than r, at that time, what is the relation between I and r? What is the relation between I and small r? Inversely proportional to r cube is okay. R bar I am talking about. What is the relation between I and r directly? I is directly proportional to r only, right? Whenever you get I is directly proportional to r, what will you get? Straight line. Straight line, nothing but will get in this way. Correct? So that our graph will be like this. Clear, right? Time is over. Just calculate that one. Just copy the derivation. With r it will be r square, no? I is inversely proportional to r square will get. Magnitude of r, nothing but. With the direction, what will get here? Directly proportional to r. With the direction I am talking about. With the magnitude, how much it will be? Inversely proportional to r square. Inversely proportional to r square, nothing but what will get? Parabola na hyperbola na? Inversely proportional to r means hyperbola, r square means parabola. Of that one.